Here's another video on the GM Chevy S10 4.3 supposed oil cooler delete. You can see this is the spacer. This is called an adapter in the GM manual. Has a bypass thing built in. I've taken out the about 3/4 inch threaded filter tube. The tube what threads into this unit and the filter threads on it. And that goes to the engine and the two screws and the gaskets. And you'll find many videos on YouTube and wannabe forum experts discussing this. And I'm going to show you they are all wrong and dangerously wrong. Not only a danger of instant destruction of the engine, but also, if that happens, possibly getting you involved in an accident. They're kids doing a simple job of taking out two bolts and screwing a filter in. The difference on my videos is I have the engineering background to design this system. I'm going to show you why they're wrong and the correct way to do this doesn't destroy your engine. This is not a subject area for everyone's opinion. These things can be dangerous. They can be dangerous to your life and safety. That's why engineers do these things, not hobbyists. Here we are under hood, and here is one of the oil cooler lines. See the flare on the line? There are O-rings that go on those flares on each end of both hoses. They were both crushed, destroyed. I had to dig them out of the radiator and dig them out of the filter adapter housing. And what the children making videos don't show you, never show you, is the after. They unbolt something, bolt something on, that's the end of the video. Did their engine blow up? You don't know. They don't show you. Here are my results. Okay, watch oil pressure gauge. 60 psi. Since I've deleted this system, supposed oil cooler system, the oil pressures are across the board, across the cold to hot temperature range, except for full hot idle, are 10 to 15 psi higher. We might expect that because of the fluid resistance in the hoses and the supposed cooler in the radiator. And notice I keep using this term supposed cooler because I'm going to explain to you shortly that that is not an oil cooler. That is a heat exchanger, not a cooler. And the oil pressure readings across the operating temperature range prove that. As I drive this thing, I'll turn the video back on to show oil pressures. This is full cold. The temperature goes up to about one minor division above the first major division. Excuse me, about 165-ish. People that aren't about 40, maybe 50 years old have forgotten or never knew that it is vital to let engines warm up. Don't fall for the environmentalist lies about it wasting fuel. It spends droplets of fuel instead of cups or quarts driving a cold engine and prevents long-term severe engine damage. Notice this engine is 308,000 miles and 60 pounds oil pressure. What's that tell you? We warm our vehicles up. Nice, slow, steady, no torque drive to get the water temperature to start coming up. We, meaning wife and I, who are engineers that have every aspect of engineering covered except civil and structural, but including nuclear, define warm up as the temperature gauge reaching the first mark, which is in this vehicle 100 degrees. That's started to warm up, especially if you're from cold areas such as the North U.S. You'll quite likely get in the winter and start the thing up, go back in the house, let it warm up, because you don't want to get out and drive a cold vehicle. That illustrates the point. Okay, driving, engine barely over 100 Fahrenheit, the oil pressure is reaching 65 pounds. During this warm-up drive, very light throttle, light duty. Okay, This system with this adapter and filter stud and lines and radiator are not an oil cooler. That is wrong. That is a second or third level description. That's a sub-definition. The system is a heat exchanger. Oil to radiator coolant to air. So it's a liquid to air heat exchanger. There are two heat exchanges involved, not just one. So firstly, it is wrong to just call it an oil cooler because it's an oil to antifreeze to air cooler. A heat exchanger allows heat to transfer from a reservoir of higher energy under the first law of thermodynamics to a reservoir of lower energy, never the other direction. The other direction violates the laws of physics. There must be a driving force. This system then can transfer heat two directions, from the oil to the coolant if the oil temperature is hotter than the coolant, and the hot water temperature in this vehicle at a max ought to be about 195 Fahrenheit. Coming up to temperature still over 60 pounds. So that means that the engine oil would have to be probably 250 Fahrenheit or more to have any effective heat transfer, and it is quite possible for engine oil to get that hot. Valvoline GM spec ATF, as I recall, that was probably back in the Dex 4 days, was good to up to 400 Fahrenheit. Of course, this is motor oil, not transmission oil, but that ignores the fact that when the engine is cold, there's no oil cooling because the oil and the coolant are the same temperature. What I just said about people that don't know any better or are too young to remember jumping in and driving a cold engine, because we have better made engines and fuel injection and control computers and on, we have vehicles since about the 1990s with which we can jump in, turn the key, adjust the mirror, and drive away at full speed. That is death on engines. You will destroy that engine 1 to 200,000 miles too soon by doing that, because the oil has not had time to warm up and go down the viscosity index curve down to the correct operating viscosity and temperature. That oil might be 10 viscosity at 80 degrees. The operating viscosity is less because that's chosen to be the correct viscosity when the engine is up to, say, 190 degrees. Driving with cold oil reduces the flow, starves the bearings for oil because the oil is too thick. What this system does is not oil cooling. Okay, see here? Coolant temperature, 165 because I've measured it. Oil pressure, still cold pressure. That means that the oil is still cold. Terry Smith, a racer and owner of Cincinnati Speed in Sharonville, Ohio, back in the 80s, said he had an alcohol car. He was a real drag racer. And he said he did a test run one day. He got the engine up to full temperature, made a quarter-mile run, and came back, measured the oil temperature, and the oil was only 140 degrees Fahrenheit. This is because in a drag engine, most of the heat is exhausted through open exhaust headers. In our vehicles, we can't do that, so we use radiators to take the heat away. But the oil, the majority of the oil, is lower down in the engine where the temperatures aren't that high and where there's also coolant. There's minimal oil put to the top end of this engine, so the oil picks up minimal heat. That's the valve train. What this system is not a cooler, it is an oil heater. And the purpose of that is for these people that throw the key in, turn it on, and stomp on the gas and go full speed right away, to reduce long-term engine damage by helping the coolant, which is warming up, to also warm up the oil. And this engine has been at full operating temperature for the past several minutes. Look at the oil pressure now. Down to about 50 some. Now the full hot stopping in the city idle oil temperature with the AC on, full load, full heat, is about 30 psi. So that proves that even though the coolant reads up, the bottom of the engine is still cold. There's no coolant and no heat supplied to the crankshaft and the bottom of the rods. There's heat supplied to the piston rings and the cylinder walls through conduction of heat from the piston crown down through that system. But that heat doesn't really reach the rods. So the rod bearings and the crank bearings and the oil pump are still cold. So it's a mistake now for me to go drive this full tilt because the oil's still lagging behind in temperature. And these readings right here prove that system is an oil heater, because before this, that oil would have been thinned down already. Now the problem with this modification that's done by all these wannabe YouTube experts, which are 29 years old and don't know anything, is that they're going to cause you to blow your engine sky high. I talked with a service advisor at a local GM dealer who gave me this false narrative of you can't remove that because it's a cooler, and if you remove it, something horrible will happen. But he had no idea what. Simply just a false reasoning that it's an oil cooler, so if it's removed, the oil will overheat, and that is a lie. False. You see, I asked a mechanic an engineering question. Of course, he couldn't answer it. He doesn't know anything. The horrifying mistake that you'll find out when driving down the freeway, the oil light comes on and the engine locks up, is that the children making these videos don't have enough knowledge, especially no machinist knowledge, which I have, machining, fabricating, and welding on top of everything else. They don't understand that when that adapter is removed and the oil filter threaded tube is removed, that what I found when I threaded that tube up into the engine block and screwed on the oil filter is that that's wrong, because the filter was only holding on by 2 threads. At 60 psi oil pressure on the bottom of that filter can, which is about 3 inches in diameter, calculate the surface area of the bottom of that can, ignore the hex, just assume it's round. Multiply that by 60 pounds per square inch and see that there's probably 150 to maybe 300 pounds force on that filter can trying to push it off those threads. There are, I think, 5 threads in the filter. I use a Delco filter. The stud threads too far up in the engine block, and that's a risk of damaging, breaking the threads and blowing the filter off. And you think an oil filter leak is bad, blow that filter off and have the pump pumping full volume out that great big hole. It'll pump the oil pan down in a few seconds. So what's necessary to do is either put a washer between that stud and the engine block to space that stud down, or what I did, since the threads in the block are legacy and never been used, there's oil residue burned into them, I put a little bit of blue Loctite medium strength paste on the threads. There's no need to coat them. We're not worried about leaks here. But a small amount of Loctite, and thread that stud up into the block, and then let that Loctite harden overnight before putting oil back in the system. And I did so after unthreading that tube far enough to give about 5 turns engagement between the oil filter and the stud. It was about 4 to thread it on till the oil filter seal contacts the engine block surface, and then 3/4 turn to tighten it is basically 5 turns. That's basically full thread engagement. Do what they tell you in these videos and kiss your engine goodbye. After driving several miles, see the oil pressure is down to 45 to 50. Now the oil gauge responds to the throttle and the load. I'm coming to stop after 15 minutes, and now the hot idle oil pressure is 40. So the overall pressures are up, but this proves that is not an oil cooler, it is a heater. And that, again, that's proven because the full hot summer day AC on come to a stop idle pressure is the same as it was before. So there's no cooling going on. Yes, there could be some cooling in an extreme case. This is a pickup truck, put half a ton load on it, drive it uphill in a 100-degree day. There might be some temperature peaks on the oil. But the coolant's going to be hotter also. So this truck is never going to see that kind of service again. We use it for driving around town, keep the miles off a new Ford. So all this truck is to us is basically something to go to the grocery store in. So no need for oil cooling. What the service writer told me at GM is BS. GM probably made 150 million corporate-wide 350 engines, and this V6 is a 350 with 2 cylinders cut off. Those didn't have these magic oil coolers. Many of them are still running. No, they didn't burn up. So the service writer was simply making up a story to try to sound important and got caught by an engineer. So there it is, folks. The system is not an oil cooler. It's an oil heater. And here we are after 20 minutes, full hot engine. Oil pressure is a touch higher than it was on the 85 to 90 degree day yesterday, but essentially the same temperature on a full hot engine, which proves this is not doing cooling. So the summary is that this system is not an oil cooler. Notice the supposed oil cooler is on the inlet side of the radiator, which gets the full temperature coolant from the engine before it has been cooled. That implies it's a heater. Notice the other side's the transmission. That is on the cold side of the radiator. The transmission is stuck back there in a pocket with coupled engine heat and radiated exhaust heat and poor airflow. So yes, the transmission does need cooling. Don't disconnect the transmission cooler unless you add an external oil to air cooler, which would actually be a good idea. Also, don't pay attention to the fools that make these videos and forum comments about just take that threaded filter stud out and screw it in the block. They'll cost you an engine. So this is not a topic for mechanics. This is an engineering topic. Fortunately, I have the engineering knowledge and 40 years of automotive experience to catch these kind of mistakes and show you the correct way to do it.